Okay, so we're looking at 3D Pythagoras today. So this is definitely a little bit trickier than 2D Pythagoras, so if you're not comfortable with that, I'm going to put a recap video on as well, a Corbett Maths one. I'm only going to go through one example because they are quite long, so I will also attach the Corbett Maths 3D Pythagoras as well, so you'll have another example from that too. So you will have two examples of the 3D Pythagoras. I will also, with the exercises I attach, I'll put one for the 3D Pythagoras and also just a general Pythagoras one so you can do some practice before as well. This is right at the top end. These are generally worth quite a few marks. It's about as difficult as the Pythagoras stuff gets. So just be aware when we're doing this. This is a tough topic. So if you are finding it hard, that's completely reasonable. And if you do feel like you benefit more from just doing some general Pythagoras practice, feel free to do that. Okay, so just a quick recap on Pythagoras before we start. So for a right angle triangle, the sum of the areas of the two small squares is equal to the area of the larger. So we've got a squared, so that's one of the smaller sides. The area of b, so that's b squared. And c, so the area of that would be c squared. And that's because all of these are squares. So the area of square a and square b, if we add them together, it would get the area of square c. So that gives us a squared plus b squared equals c squared. And I'll put a link on YouTube. There's some good devices that show this, so I'll just see if I can find one of them to link. Okay, so on to the 3D Pythagoras. So we've got I guess theoretically a real life problem. It's a spider in a room spinning a web from one corner to the other. So it's going diagonally across the room. So it's starting off in this corner and its web is going to end up in this corner. We're going to assume that the web is a perfectly straight line, and we're going to try and calculate the length of that web, so from one corner of the room to the other, and we're going to do that using Pythagoras. Okay, so the first thing to do is work out where the right angle triangle is here. So when we've just got the line, it's not necessarily obvious, but we can see that what we can do is, if we draw this line down, and this line across, we can see that we do have a triangle there. Not very neat. And because this is meeting the corner of the room, this will be a right angle. So it's going from the floor and it's going up to the wall, so that will be a perpendicular. So that means that this is 90 degrees. So we've got a right angle triangle there. And the width of the room is 10, the length of the room is 16. So while we do have a right angle triangle here, we could start thinking about Pythagoras. We don't actually have this side length yet. So if we don't have that, we don't have both of the small sides. So basically, let's redraw the triangle that we've got here. So we've got a triangle that looks like this. We've got this side here, which is 8. We want to find this one, but we don't have this one yet. So we can't do Pythagoras on this yet. So what we need to do then, we need to work out this side. And we can do that by using Pythagoras first. So we're going to have to basically use Pythagoras twice. So imagine I'll use a different colour to make this clear. We've got actually another triangle here. So let me just find my pen. So we've got a second triangle here. So again, a shared side here. Then we've got this side and this side. So again, redrawing that triangle. So we've got a side of 10, a side of 16, and then the diagonal that joins them. So we've got 10 meters, 16 meters, and again, because this is a corner of a room, we can assume it's a rectangular room, so that would be a right angle there as well. And this side here is this side here that we were missing before. So if we can work out this, we'll call this one x. That tells us this side here. And then we can find out the side that we're looking for. So we're going to have to do 2 steps of Pythagoras. We've got step 1, which is work out the line on the floor. And then step 2 is work out the diagonal across the room. So we've got our right angle triangle shaded in there, that's our first one. remove all that, we've got our first right angle triangle. So this is the one that is on the floor. So let's work out this one. So we've labelled our sides up. So we've got our two short sides, that is 10 and 16. So we'll call this one A, this one B. Doesn't matter which way around you do it. So A squared plus B squared equals C squared. So the only key thing with Pythagoras is the longest side has to be the one that's on its own. So we've got A squared plus B squared equals C squared. So we've got A and B are the small ones, C is the big one. So then we just substitute in. So we've got 10 squared plus 16 squared equals C squared. So we can substitute in, so 100, 256 equals C squared. So add them together, 356 equals C squared. So that tells us C equals root 356. So you're going to need to use a calculator for this, but I've already got it here. So we've got x is 18.867. So we'll make a note of that because we're going to have to use this in our next calculation. So getting back to our diagram, we've now worked out our line on the floor, the diagonal going from this corner to this corner. So now we can go back to our right angle triangle from before, the one that actually includes the diagonal across the room. So we've got two of our sides now. So drawing that triangle out, we've got a height of the room of 8, and diagonal going across the floor of 18.86. So again, we're going to have to use Pythagoras on this. So we've got our missing side, which we've called x. In fact, this is a different x to earlier, so we'll rename this one x. The one from earlier is a different x, so not very good maths there. I should have used a different letter. So we've substituted in the two small sides squared. So we substitute them in. We've got 356 plus 64 equals x squared. Then simplifying down, x squared equals 420. So then x, we square root both sides and we get 20.49. So the diagonal across the room is 20.49 meters. So we've used basically Pythagoras twice. So although 3D Pythagoras, it's not a different method, you're just reapplying the same method. And the tricky part, I think, is spotting which triangles to use. So as I said, I will link the Corbett Maths video as well, because the examples of this are quite long. I've spent 8-ish minutes on this one example. So it'd be quite a long video if I do more than one. So I'll just do this, and I'll also link the Corbett one too. But as I say, because this is right at the top end of Pythagoras, if you do feel like you're struggling with just the general Pythagoras stuff, I would probably have it practice with that first. Yeah,